Man, you guys, these stats problems are so hard. I don't know
Yeah.
anything about type 1 or type 2 error. I don't even know what it is.
I don't get it either. I mean, it's really tough. Mick, can you help us?
Guys, for the last time, type 1 error is when you reject the null hypothesis when it's actually true. And type 2 error is when you fail to reject the null hypothesis when it's actually false.
How is it actually applicable in real life?
As a wise man once said, shnikes. And because of that, South Park made an episode using the Bee Gees to destroy the Fertile Crescent.
Hey Ben, you see that girl over there?
Yeah.
She's real good looking, isn't she?
Yeah, she is. You should go talk to her.
Are you kidding me? She would never go for a guy like me. That's a joke. I have no chance.
Wow, I wish that guy would really come up here and talk to me.
Hey, you should go talk to that girl over there.
You know what? I'm gonna.
Go, man.
What's up, Mama?
Now let's learn the math about type 1 and type 2 error. As you can see, I wrote down so you guys could remember which one is which. When you reject the null hypothesis, and it's actually true. Wait, what? That's type 1 error. If you reject the null hypothesis when the alternative is true, that's a good thing. Then, if you fail to reject the null hypothesis, and it's true, good job. You guys did it right. Fail to reject the null hypothesis when the alternative is true, that's type 2 error. Now, do you guys remember which one is easier to calculate?
No, we don't.
Type 1.
Why is that?
Because all it is the probability, or is the significance level of the x bar that you use. Now, type 2 error is completely different. For that, what do you need, class? What do you need?
Spiders!
Not spiders. They're bad for you. You need the alternative hypothesis. Remember, kids?
No.
That's why y'all failed the AP test. Now, when doing type 2 error, you have to find the probability of the the x bar from going to the left. I believe this is left. Left.
I'm left to your left.
The board's left. Using the information from the alternative hypothesis, which is the true one, because as type 2 error shows, the original one is not true. These things are false. And that's just the type 2 error right there. Now, what is power?
Well, if you increase it, doesn't that make for a better test?
You're right, Connor.
Woo!
There's a treat for him.
Nobody likes you, Connor.
Off, Ben.
Guys, I don't like it when you fight.
Okay. Ben, what do you know about power? How do you calculate
Nothing.
it?
He's stupid.
Dan?
I know that increasing the sample size increases power.
Connor just said that.
What?
Power is simply 1 minus anyone?
N.
N? No.
N times P.
Yeah.
Yes, kind of. No, not at all, actually.
1 minus sample size?
No.
That's also N.
Once we realize what type 2 error is, and we want to find the power,
Ooh, 1 minus type 2.
there it is. Good job, Connor.
Nice.
Ben's way ahead of you.
I'm ahead of
Okay. Now, different types of tests, you would think that there would be different types of type 1 and type 2 error. But in our travels, at the great Vassar.net, any questions, refer to them. In our travels, we discovered that a z-test, what is a z-test and t-test, what's significant about them, class?
Ben knows.
They use X bar.
They use x, no,
Yeah, they do.
only one uses x bar.
Yeah, they both do.
Anyway, They both are what shaped?
Bell.
Bell, also known as
Normal.
normally distributed.
Proportion.
Nice guess. Now proportion. What kind of curve do we use for that?
We don't use a curve.
Not normal.
No, it's still normal.
Normal.
It's still normal, so you use the exact same one.
Weird.
You see how where this is going to be the same sort of thing?
No,
Yeah.
explain it.
Chi-squared test.
Chi-squared?
Normal.
No, not normal.
Damn.
But it's the exact same thing. Right there. There's your chi-squared. Squared statistics. And type 1 errors, same thing. But for type 2 error, what will you need? If you have the original chi-squared, what do you need?
The alternative hypothesis, chi-squared.
There you go. There it is.
Why don't I get a high five, Auschwitz boy? Skinhead.
Yeah. Now, what about lines of regression? Can they have a type 1, type 2 error?
No.
Why?
Because you're just testing regression.
You're testing whether or not there's a correlation between the two.
There you go. Good job, Ben. Paul, high five.
Now, Paul, did you really learn anything from any of this?
This is awful. What kind of a jerk teacher teaches this? I'm out of here.
Now that we know the math behind it, what are some more real-life situations?
Hey, kids!
Should I attack him or should I run?
Now we're going to go through a walkthrough on VassarStats.net. Well, to kick things off, you can simply Google VassarStats.net and go to the website, and it has a blue heading, and it says Vassar Stats website for statistical computation. At the top, it'll say Welcome to Vassar Stats website, and there'll be a site map that you can navigate to determine whatever and help you accomplish whatever you're trying to accomplish. Over to the side, for our example, we are going to go to T-test and procedures on the left-hand sidebar, and you can click on that. And it'll take you to a T-test and procedures menu, and you can determine which type of T-test you are trying to accomplish. We are going to go to 2 sample T-tests for independent and correlated samples. And then this is a super handy tool because you can simply type in all of your sample A and sample B data where it says data entry, and you can type in your data summary and all of the other data that you received while you're computing your test. At the bottom, you can hit calculate, and it will give you all of the data that you need to make a proper statistical test. This is a really handy website because it pretty much covers everything that we have went over the entire year in statistics, and it's useful for any future statistics classes or situations that you may find in your life in which you warrant the use of a statistical test. Basically, for type 1 error, the simple definition of type 1 error is it is the area to the right of the x-bar value. To calculate type 1 error, you need to find the standard mean and your x-bar value. Because type 1 error is the area to the right of your x-bar value, type 2 error will be the area to the left of your x-bar value after you adjust it for the alternative hypothesis. So your type 2 error, you need the x-bar value as well as being able to adjust your x-bar value for your alternative hypothesis. A lot of times it's easier to find type 2 error after you find type 1 error first. An interesting fact about type 2 error is that it is generally higher for chi-squared testing. For type 2 error, it is generally higher for chi-squared testing because chi-squared tests are right skewed. In short, Vassar Stats is an awesome tool for accomplishing anything statistical that you may need to accomplish after Mr. Hatlin is no longer in your life.